Now we are almost in our last set of problems of chapter 10. So let's do question number 5. So question number 5, what it says, let's read it. Show that the 4 points with position vectors are coplanar. Now they are talking about 4 points in here. So first thing, when we hear points, so we can find vectors joining those points, right? So let us give the name of those points. Let A is equal to, the first one you write 4i cap plus 8j cap plus 12k cap. So this is our first point. Now B vector is equal to, so it is 2, 4, 6, 2i cap plus 4j cap plus 6k cap. Now our third one is 3, 5, 4. So C is equal to 3i cap plus 5j cap plus 4k cap, right? Now our last one is 5, 8, 5. So D vector is 5i cap plus 8j cap plus 5k cap, right? So now we have these position vectors of 4 points. So now can you tell me what will be AB vector equal to? A vector joining 2 points. So it is what? The components of B minus components of A. So we have what? 2 minus 4. Okay, let's write 2 minus 4 I cap plus 4 minus 8 j cap plus 6 minus 12 k cap, and that is equal to minus 2i cap minus 4j cap minus 6 k cap, right? Now BC vector will be what? BC vector will be your C minus B, so it will be 3 minus 2i cap plus 5 minus 4j cap plus 4 minus 6 k cap. So you are getting I cap plus j cap minus 2 k cap, right? Now last one, CD vector. So CD vector will be your the components of D minus the components of C. So it will be 5 minus 3i cap plus 8 minus 5j cap plus 5 minus 4 k cap, and that is equal to how much? 2i cap and plus 3j cap plus 1, or should I write just k cap? Clear? So we got 3 vectors. Now they're saying that we have to show that these points, that they are coplanar. Now how can 3 vectors be coplanar? We already know their scalar triple product is equal to 0, right? So write down in here. So the vectors AB, BC and CD can be coplanar when their scalar triple product is equal to 0, right? So let's do the scalar triple product then. So what we have, AB, BC, this was it, right? Now if I have to write this one as AB vector dot BC vector cross CD vector, right? And that is equal to, we know how to do it, draw determinant sign. Now what are the components of AB? The components of AB is minus 2, minus 4, minus 6. The components of BC are 1, 1, minus 2, 1, 1, minus 2, The component of CD are 2, 3, 1. Clear? Now let us expand. I'm very sorry. So let us expand this one. All the components we have written in here. So now if I expand this one, in which let's expand in the row 1, along row 1 only. So if I take minus 2 out, so what we have, 1 into 1, that is 1, plus 6, then plus 4, there is a minus sign already there and minus sign already in there, so minus minus becomes plus 4. This one goes, 1 into 1, that is 1, minus sign is there, so it will be plus 4, and then we have minus 6, this one will be 3 minus 2. So how much you have? 6 plus 1, that is 7, so it will be minus 14, and this one will be 5, 5 4s are 20, and this one will be 3 minus 2 is 1, so minus 6, and this is equal to 0. Hence the points A, B, C and D are coplanar. Okay, actually we have to write so we can write that hence the points with position vector A, B, C, D are coplanar. Understood? So the scalar triple product has to be 0. Then we can say that those 4 points with position vectors A, B, C, D are coplanar. Now we will be doing question number 6. So what it says is find X such that the 4 points A, B, C and D are coplanar. So A is given by 3, 2, 1. B is given by 4x5. And C is given by 4, 2, minus 2. And D is given by 6, 5, 1. 6, 5 minus 1. So you have to find the value of X for which these points are coplanar. First thing, we have learned how to find vectors joining 2 points, right? So let us find the vectors joining the point A and B. So AB vector will be equal to what? Just like the previous one we did. So it will be 4 minus 3. So it will be I cap. 4 minus 3 is 1. So it will be I cap. Then we have plus x minus 2 j cap. Then plus 5 minus 1 k cap, right? Then BC vector will be what? BC vector will be 4 minus 4, that is 0 I cap. Then 2 minus x j cap. Then minus 2 minus 5, that is minus 7 k cap. Now CD vector will be what? CD vector will be our 6 minus 4, that is 2 I cap. Then 5 minus 2, that is plus 3 j cap. Then minus 1 plus 2, that is plus k cap. Understood? Now if these 3 points are coplanar, since AB, BC and CD are coplanar, then their scalar triple product is equal to 0. Acha, one thing you might be confused that A, B, C, D are coplanar. They haven't said that A, B, B, C, C, D are coplanar, right? So you see here, if I have a plane like this, there is a point A, there is a point B, there is a point C, there is a point D. So if A and B are coplanar, so the vector AB lies in the same plane, vector BC lies in the same plane, vector CD also lies in the same plane. So AB, BC and CD, they are also coplanar, right? Understood? So now the scalar triple product is equal to 0. So what do we have? AB, BC, CD equal to 0, right? So what is that? AB vector dot BC vector cross CD vector equal to 0. Now we know the determinant form. What is the determinant form of this one? So what are the components of AB? AB is what? 1, x minus 2 and 4. 1, x minus 2 and 4. Then what is the components of BC? It will be 2 minus, look at here. For BC there is no I cap, so it is 0, 2 minus x, we have minus 7, and for CD it will be 2, 3, 1, and that is equal to 0. Am I clear? Understood? So now for the expansion portion, let us expand. Now after this, what do we see? Expanding along C1 will do, because here is a 0. So expanding along C1. So what do you get? If I take out 1, so it will be 2 minus x into 1. So I write 2 minus x. I didn't know to do the bracket sign. Fine, let's give the bracket sign. 2 minus x, then minus of plus 21. So this is what I get. Now you have, what sign will it be? It is what? It is third row, first column. So 3 plus 1 is 4. And 4 is what? Positive, right? So this one will be plus. So plus 2. And this one will come out to be x minus 7. Minus 7 into x minus 2. And you have minus of 4. This one will be 2 minus x. Let's give second bracket in here. Okay. Now let's simplify. So what do we have in here? We have 2 minus x plus 21, and here we have plus 2. Minus 7 into x is minus 7x, and this one will be your, how much will it be? Plus 14. Then this one will be a minus 8, and this one will be a plus 4x. That is equal to 0, right? How we can forget this equal to 0, because scalar triple product was equal to 0, right? So this is what I get. Understood? So now it says, so let us simplify this. So this one is equal to how much? This one is your 21 and 2, that is 23. 23 minus x, and here what you have is minus 7x and 4x, that is minus 3x. So we have minus 6x. Clear? And 14 minus 8, that is your 6. 6 to the plus 12 equal to 0. So minus 6x minus 7x, and 23 plus 12 is your 35. And goes that side, becomes minus 35. Therefore x is equal to 35 by 7, and that is equal to 5. That's your answer. Now we have here the last question of this chapter. It's question number 7. So first thing what it says, show that the vectors A, B, C are coplanar if A plus B, B plus C and C plus A are coplanar. Okay, so now if A plus B, they're saying that B plus C and C plus A are, if they are coplanar, what you can say about them? The first thing comes into our head is that when three vectors are coplanar, the scalar triple product is equal to 0, right? So since these three vectors are coplanar, I can say A vector plus B vector then you have B vector plus C vector, then you have C vector plus A vector. The scalar triple product is equal to 0, right? Now let's write this one. A vector plus B vector dot, the inside one will I write like this, B vector plus C vector multiplied by C vector plus A vector equal to 0, right? Now we know, now let's always we do BODMAS, right? Always do the work which is in the bracket. So let's do it first, this one. So A vector plus B vector. So first thing you see the cross product. Now we know one thing, that cross product is distributive, right? So let's distribute this one with this one, just like multiplication we do, normal algebraic multiplication. So B cross C plus B cross A plus C cross C plus C cross A. Can anybody tell me what is C cross C equal to? C cross C equal to, how much is it? It's cross product of the same vector, and cross product of the same vector is equal to 0, because a vector makes 0 degree with itself, right? And so sine theta, that is sine 0, is equal to 0. So that's why C cross C will be 0. So this whole expression becomes easier now. So it becomes B cross C plus B cross A plus C cross A. Clear? Now let's do the dot product with each one of them. What do we have? A dot B cross C. A dot B cross C. A dot B cross A. A dot C cross A. Plus B dot B cross C plus B dot B cross A. Last one, plus B dot C cross A. That is equal to 0, right? Now can you tell me which one of them are 0 in here? I told you scalar triple product, when two elements of the three vectors are same, then the scalar triple product is 0. So which among this we have the same two vectors are there? This one, this one, this one, and this one. So all the four are 0. So what we are left with? We are left with A dot B cross C plus B dot C cross A equal to 0. Now look at here, A dot B cross C and B dot C cross A. Let us roll back to our time of scalar triple product. So suppose I say A in here, I say B in here, I say C in here. So ABC, this one is what? ABC. So ABC goes in anti-clockwise direction, and BCA also goes in anti-clockwise direction. Yes or no? So both are equal. So if I write this one as A, B, C, can I write this one as A, B, C? Understood? Now, so what we have? 2 of A, B, C equal to 0. Therefore, A, B, C equal to 0. So the scalar triple product of A, B, C is equal to 0. That means what? The vectors A, B, C are coplanar. Hence, A vector, B vector and C vector are coplanar. Clear? So that's it. We finished with our vectors. The next lesson we will start is our 3D vectors, 3D geometry, which is quite related with this vector. Clear? So that's it for today. Thank you.